squeezing, the amount of blood in there isn't changing, so same volume, isovolumic. It's also worth noting that at this point, the atria have relaxed enough that blood from the veins is starting to enter them again. So venous blood beginning to fill the atria. And this will last until the pressure in here builds up to the point where it's greater than the pressure in the arteries. So here in the arteries, that pressure is slowly falling as blood is draining away out into the body. The ventricles are squeezing harder and harder, and shortly the pressure in here will rise above arterial pressure. And we will enter the next phase, which is ventricular ejection. So at this point, ventricular pressure is now greater than arterial pressure, which means the semilunar valves open and blood begins leaving the ventricles.
Is this the starting of the second phase of just...
Second phase of ventricular systole. Yep.
Got it, okay.
Project for the little Elmo thing.
For the moment, yeah. So this is kind of the point. We're now squeezing hard enough that blood is leaving the heart, going out into the arteries, and going off to the lungs or the rest of the body, depending on which ventricle we're talking about. And so the ventricles squeeze, and then they start to relax, which should start happening about the time of the T wave. That's the beginning of ventricular repolarization, which should be about the same time as we relax, as we start to really relax the ventricles. Which means ventricular contraction is now ending. Now we're entering into ventricular relaxation, or diastole. The first part of which is called isovolumic ventricular relaxation. So at this point, we've opened those semilunar valves, blood is leaving the heart. And now the ventricles start to relax. Yes?
Is that still part of the ventricular
Systole went up to here,
system? Okay.
and now we're in diastole. So as the ventricles now start to relax, the blood I just put into the arteries under high pressure is going to try to flow back. The arterial blood is now under high pressure from all that ventricular blood I just shoved into it. So now the ventricular pressure is going to be lower than the pressure the arteries can exert. Ventricular pressure is less than arterial pressure. So which way is the blood going to try to go?
Ventricles?
Yep, arteries back to ventricles. Will those valves allow that?
No.
Nope. That causes our semilunar valves to shut. What happens to the last bit of blood flowing through a closing valve?
Makes a sound.
Turbulent, and we get our second heart sound. Dub. Yep. I've read a couple texts that call it dup instead of dub. I hear. Yeah. Dub. So the pressure has fallen enough that arterial blood tried to flow back, valves closed, we got dub. The atria have been filling with blood from the veins, but that blood is under extremely low pressure. So the atrial pressure is still quite low. And we're back to this problem where we're between the two. We're lower than arterial, but still greater than atrial. The ventricular pressure is still greater than atrial, which means the AV valves are still closed. So the trash compactor wall has started to back off. People are no longer fleeing in panic through that door. The people who are out there say, hey, it's crowded in here, and that room's okay now, and they start trying to come back and the door closes. There's people in that room wanting to come in, but we're still all shaky and bouncing around the room, so we're still holding that door closed. But as the wall backs off, pretty soon everyone calms down and spreads out. And after a moment, we're going to go back into atrial and ventricular diastole, which is the later part of ventricular diastole. And it's also where we started. So at this point, ventricular pressure goes below atrial pressure, which means the AV valves open. And we're back to where we started. That's the cardiac cycle. Now the next thing for us to do, and I'll let people finish writing this, is to try to put all of this together. The pressures in the atria and the ventricles, the ECG, the amount of blood in the ventricles, the heart sounds, all of that onto one chart that goes in, follows those in time and shows how all of them are changing. That's the Wiggers diagram. And so we are going to start. This is on page 494 of the 6th edition. A similar diagram will be in all the other editions as well. I think what we're going to do first is try to draw one of our own from scratch, and then we'll walk through the one in the book. We'll see how close we can get. Now, I will tell you right now, I am not going to ask you to draw a Wiggers diagram from scratch on the exam. But I will probably say something like, here's a Wiggers diagram. This line is missing. Fill it in. Make sure it crosses all the other ones at the right places. I recommend that you practice doing this until you can draw a Wiggers diagram. Once you can do that, you probably understand this pretty well.
Dr. Rod,
Yes.
is it better to draw this one horizontally on the paper or vertically on the paper?
Vertically is fine, but make it nice and big. Yeah, portrait mode is fine, but I would have it take up a good fraction of the paper. So this middle section is going to be for pressures. We'll put arterial in, we'll put that in purple. We will put ventricular in red, and atrial in blue. here we will have ventricular volume, the amount of blood in the ventricle. Up here we'll have ECG. Let's start at the same place. We'll start at atrial and ventricular diastole. So during atrial and ventricular diastole, venous blood is filling the atria, so what should be happening to the atrial pressure? Up. It's still not very high, but it should be slightly rising. How about the ventricular pressure? Blood is draining from the atria to the ventricles. So what should be happening to the pressure in the ventricles as blood enters them from the atria? It should be less than the atrial pressure, but rising along with it. From the previous heartbeat, we put a bunch of blood into the arteries. That is still under pressure, but it's draining as that blood goes to the rest of the body. So arterial pressure will be higher, but falling. Do ask questions as we go here. Okay. Our ECG is not doing anything yet. Now, how about the amount of blood in the ventricles? As blood is coming to the ventricles from the atria, the amount of blood in the ventricles should be rising somewhat. Can you see okay?
No, none of us got there, Ken.
Okay, let's see, what can we do with this?
It's not that, it's also the colors.
Oh,
It's just hard to see from back there.
I'm sorry.
It's okay.
We don't have as many colors as we used to. Microbiologists, they don't like them. Anyway. All right, so that's what's going on during atrial and ventricular diastole. The next thing that happens is we go into atrial systole, meaning we're going to need a P wave to start it off. Let's bring this out just a little further before we do that. Okay. So let's start a P wave. The P wave is going to be the official beginning of atrial systole. Now, during atrial systole, our twitch in the atria starts, which means the atria are going to contract. What will that do to the pressure in the atria? Should rise. So what should my blue line here do? Yep. Like so. And as that shoves a little extra blood into the ventricles, they're going to do the same thing. That means that the amount of blood in the ventricles is going to take a little bump. What does that do to the arteries? So if my atria are squeezing a little extra blood into the ventricles, is that going to do anything to those arteries? Not really. So their pressure really doesn't respond to that. Okay. So there's atrial systole. The next thing that's going to happen is isovolumic ventricular contraction, which will begin with the R wave. Okay. With the R wave, the ventricles begin contracting. What's that going to do to the pressure in the ventricles? It's going to start rising. And notice, it's right below atrial, so as soon as it starts rising, it's going to cross over atrial pressure. That's the point at which ventricular pressure goes above atrial pressure. When that happens, blood tries to flow back from ventricles to atria. What happens? The lub, the atrioventricular valves close. Let's mark this. This is a special moment. Here's our heart sound. Okay. So ventricular pressure is rising, but it's still below arterial. This is what I was hoping would become clear here. The ventricular pressure is above atrial, but lower than arterial, which means the semilunar valves are still closed, so the blood can't go anywhere. Ventricular pressure is going to rise and it's going to exceed the pressure in the arteries. It's going to cross over there too. That's another important moment. Let's fill in a few things here. During this time, when ventricular pressure is above atrial but lower than arterial, the atrioventricular valves closed, but the semilunar valves have not opened yet, so the blood in the ventricles can't go anywhere. So tell me about the amount of blood in the ventricles. Going up, going down, or not changing? If we can't get in through there anymore, and we can't get out here, how many people are in the room, and do we get more or less? Same. So during this time, amount of blood in the ventricles is constant. This is isovolumic contraction. Now, a couple of things. The pressure in the atria is actually going to go up at this time. This is effectively because if we imagine that this is the atrioventricular valve, I'm the atria and you're the ventricles. So this was open. You started squeezing and the valve shut. And you're good enough at squeezing, you folks squeeze hard, that the valve kind of goes like this. The wall of the atria to ventricle starts bulging back a little into the ventricles, which increases the pressure in here just a little. We get a little pressure bump. Okay. So we're now, our pressure just went above arterial pressure, so now we're in ejection. Ventricular pressure keeps on going up. The ventricles say, squeeze! So now their blood is going out into the atria. Sorry, arteries. That puts a bunch of high pressure blood into the arteries. It also relieved all that pressure on the wall of the atria, so that drops back off. And during this time, when blood is going out into the arteries, what about the amount of blood in the ventricle? So the ventricular blood is now leaving, going out. So this line should go down. Amount of blood in the ventricles drops rapid. And this will last until the ventricles start to relax. That should happen somewhere around the T wave. It's going to look like this. Ventricular pressure is going to be falling, and we will reach a point at which the arteries can exert more pressure than the ventricles can. At which point, blood will suddenly try to backflow. That's the point when the semilunar valves close again. Go ahead.
Quick question, on the arterial and the ventricle, where it's going like this,
You mean right here?
yeah, between those two circles,
Mhm.
do you want it to be overlapped then, or you want which one to be?
So it should look like this. Basically, the ventricular pressure is going to go up in an arc and then down. At some point, the arterial pressure will take a little bit of a boost and it crosses over. What that is if you are the ventricles and I'm the artery, during ejection, you folks are shoving blood out in here, stretching these walls out. When you start to relax, these walls start to spring back. The blood gets shoved back, those valves close, and so suddenly there's nowhere for that to go. So the pressure here rises suddenly, just a little bump. It actually has a distinctive name. It's called the dicrotic notch. It's a sign of good arterial health. If your arterial walls are stretchy and rubbery enough to do that, that's good. That is another important moment. And for a moment here, ventricular pressure is lower than arterial, so that door's closed, but not yet below atrial, so that door's closed. So again, nowhere for the blood to go or come in. Volume is constant for a little bit here. That will be the case until the ventricular pressure drops below the atrial pressure. Which is the point at which the AV valves open back up and we are back into atrial and ventricular diastole. And that is a Wigger's diagram. Yes?
What are the green circles again, the AV nodes?
The green circles represent the times when valves open and close.
So which one's open again?
You tell me. If ventricular pressure goes above atrial pressure, blood in the ventricles is going to try to go into the atria. What will stop it? Closing of which? AV valves close. At this point, ventricular pressure goes above the pressure in the arteries. That means the valves between those will open and let blood out. Which valves are those? So this is where the semilunars open. Here's where we reverse that. The blood in the ventricles is now under less pressure than the arterial blood, so it tries to flow back. That's where the semilunars close. And here's where the valves open.
What is the atrial pressure going down with the ventricle at the beginning when the AV opens?
You mean here?
No, at the end of the chart.
Okay, so it's the atrial pressure here is rising because all the blood from the veins is filling the atria.
Okay.
Once the AV valves open, that blood can suddenly fall into the ventricles, which means the pressure in the atria drops. The ventricles are in the process of relaxing, so even though some of that blood falls into them, they're under less and less pressure. That goes until the blood draining from the veins starts to build up enough to raise the pressure in both. Think of if I'm the atria, you folks are the ventricles. So I'm filling with venous blood. Now you folks are ejecting blood out there, and then you stop ejecting and your pressure starts to fall. The moment you fall to pressure lower than what I've got, these valves open. Suddenly this blood flows into you. I go and deflate.
You have less pressure, but the ventricles will have more pressure, wouldn't they?
they have even less because they've now fallen, they've relaxed enough to the point where their pressure is less than what I have. And I've still got blood coming into me through the veins. So even though I've got some built up that then goes into you, I've still got some blood coming into me. It's going through me to you, but you're all relaxed. So I'm still going to have slightly higher pressure than you.
Because the atrium is contracted.
It's not, it's relaxed too, but it's getting new blood, which raises its pressure slightly over that.
I think it's confusing me that both the atrial and the ventricular pressure would be at the same rate.
They're not quite the same. It's important that the atrial is slightly above the ventricles, because right now, when that valve is open, we're connected. So any blood that enters me is draining through you, and kind of, we both have the same environment. It's a similar reason why the arteries and the ventricles go together here. When the semilunar valves are open, they are connected chambers.
So they would be at the same amount because they're connected and they're trying to even each other out?
Close to the same, yeah. You wouldn't get them very far apart, because if there was a big difference, you'd get a big flow from one to the other.
I think I was thinking like the atrium has the pressure and then it relieves the pressure to give it to the ventricle.
It does, but it does that when they both join together. So now they basically go to the same pressure, with the atria being a little bit greater because they're getting one. Now, if you're going to practice doing this, I do not recommend doing it the way I just did. I do it that way to explain it. If you want to practice drawing it to learn it, I recommend you do it this way. First, draw the ventricular pressure line. It's easy to draw. It goes bump, big bump. Start by doing that. Second, draw the arterial pressure. It should start fairly high, go down, follow ventricular, and then go down. When you've drawn both of those, you have two of your valve changes. The semilunars are there. That tells you where ventricular ejection is. Then draw the atrial pressure line. It's a little more complicated. And the most difficult thing is keeping track of who's supposed to be above who. That you've just got to remember, although you can kind of figure it out if you know what's going on. That gives you two more valve crossings. ECG. The P wave should line up with the beginning of atrial systole. The R wave should line up with the beginning of ventricular contraction. The T wave should end somewhere around there. then drawing ventricular volume, which you can really figure out from the rest of it.
I have a question. What's the VE that you?
That's labeling the phase. Ventricular ejection,
Okay.
isovolumic ventricular contraction, atrial systole, isovolumic relaxation, atrial and ventricular diastole. If you're trying to learn it, if you're trying to practice it, I recommend doing it that way. Because the most important things in there are getting the right thing on top of the right other thing and getting the crossings in the right place. Those 4 valve crossings are key points on this. If I gave you a Wiggers diagram that was missing a line and asked you to fill in the missing one, that's the kind of thing I'd be looking for. Does it cross the other lines at the right places? Is it above and below the right ones at the right times?
You said you wouldn't ask us to draw the whole thing, right?
I don't think I would do that, no. But if you can draw it from scratch, any question, I'll tell you, I am not going to ask you to draw Wiggers from scratch. But if you can do that, you'll be able to answer any question I would ask of you. So that's your goal. Let's see how we did. Close.
Nailed it.
This is one where I would be careful looking online. There are plenty of good Wiggers diagrams online. There are also some that are sloppy in ways that could be misleading. You'll probably find this one. It'll look just like that. That's probably a good one to go with.
So the book one's a good example.
The book one is a good example. It has the crossings in the right places at the right moments, lined up with the right things. The only thing I don't like about the book is that the names it gives for the phases of the cardiac cycle are not exactly the same as the ones I gave. But you can figure out which is which. Yeah,
That third one, is it IVC?
IVC.